Hello world and welcome to Monimax Games. Today I'm going to try and set up a camera controller for us in real time. Now the aim of this is going to be to have a camera controller that the player can actually move around your player, and that will also get a clear shot of our player wherever he is. Now let's start with the initial setup that I have here, and I'll explain what the problems are with it. Okay, right here we have our main camera childed to our character, which is our knight. And if we play, I'm going to make the knight walk around, and you'll see the camera following the knight in a static position. Okay, now let's see what happens if we turn here. As you can see, our camera is basically stuck behind the tree and we can't see the knight. And the same will apply to any other obstacles we face, like buildings and other things. Plus, we have no control over the camera and we basically are at the mercy of whatever we can see. So, let's see if we can improve this. Now, firstly, let's solve the problem of obstacles. First, let's take our camera, move it out of the way. Then we'll go to Game Objects and Cinemachine. If you don't have Cinemachine, you can go to your package manager, select the Unity package registry, type Cinemachine and install it. Since we have Cinemachine, we're just going to go Game Object, Cinemachine, and what we want today is a Clearshot camera. Now what the Clearshot camera basically is a collection of cameras. And the Clearshot camera component controls those cameras so that it can check which camera has the best view of your target, in this case our character, the player, and select that camera. It's got different priorities for each camera. So the camera with your highest priority is going to be the most likely to be shown. If that camera doesn't have a clear shot, you'll go to the next priority camera, which will have a lower number, and so on and so forth through all the cameras. Now let's set up a camera for our player here. We go to our Clearshot camera. Firstly, we're going to set our character as the look at and follow targets. Now we'll go to our virtual camera, make sure it's on solo, and let's go to the body and set our offsets. So I am going to move slightly higher by changing the Y, and I want to be a little closer, so let's change our Z as well. Okay, that should be good for now. There's lots of other settings available here, like the damping that you can set. We're not going to mess with that today. Now that we're happy with this camera, I'm going to rename it to my follow cam. And then I'm going to duplicate it. And we'll call this one our look back cam. Alright, now let's solo our look back cam so we can see what it's looking at. Basically what I want this camera to do is look from the front of the player to the rear of the player. Like when you would be standing with your back to the wall, then this view would be very useful, or even if you are trying to walk backwards, depending on the situation. Okay, now that we've set these two up, let's have a look at them. Now, On each camera, you'll see that it's got a Cinemachine virtual camera component, which basically has the transposer, which handles the body position, and it has transitions and an aim. Okay, we're not going to change anything here. Underneath that, you'll see a Cinemachine Collider script. Now, what the Cinemachine Collider script does basically is it puts a collider around your camera. If I just show you here, and it sets a minimum distance from an obstacle. And this basically what it does is, if your camera while following the player encounters an obstacle, the collider will tell the camera about it, and it will move the camera away from the obstacle. Now, this collider can be added to each one of our virtual cameras if you want different settings for each Cinemachine Collider, or you can remove it from the individual cameras and just add it to the Clearshot camera, which will be the same as having a collider on each one, but you will only have to set everything once. The disadvantage of this is that if you wanted different settings for different cameras, that wouldn't be happening here. Okay, well, we've done our initial setup. Just one more thing. We'll set our look back camera to a lower priority. Let's run it and see what that does for us. Okay, here we go. Walking, I'm going to turn around. As you can see, as soon as the tree was going to get in our way, it flipped to the look back camera. Now, this is good, but it's a little snappy. So let's see if we can make that a little smoother. We go to our Clearshot camera over here. And we say default blend mode. Currently it's on cut. That means it just cuts to the camera and that's it. We want to try and ease it in. Let's make that a 1 second. So that means it's going to ease from the one camera position to the next in about 1 second. Let's see how that changes. Okay, walking, get next to the tree, turn. And now you can see it actually seems to move from the one camera position to the next. Okay, I'm happy with that. Now, what we want to do next is we want to be able to control our camera. In this scheme, I'm going to make it so that if you hold down your right mouse button and you move the mouse side to side, that will basically pan the camera around the user or around the character. If you move it up and down, you'll move your view slightly up and down. And then finally, we want to use our mouse wheel to zoom in and out. Now let's get going with this. First step is going to be able to figure out a way to move the camera around. Now, because the camera is aiming at our character, it's going to follow our character whenever our character's orientation changes. So let's make a small change. Right click on our character and we say create empty game object, and then we'll name this our camera target. Let's grab the camera target and make that you look at and follow targets for our Clearshot camera. Where is the camera target right now? It's on our character's feet, so let's move it up a little bit. Like that. And let's change our offsets. Just to get the view we want again. Solo our look back camera. Do the same. Okay. Now that we've done that, let's do a little experiment. As you can see, we're in play mode right now. And I'm looking at my camera target, which I've selected. Now, I'm going to rotate it first around the y-axis. Notice what happens to the camera. This is because the camera tries to stay in the same position relative to our target. That's all good and well. But now look at what happens if we try to rotate around the x-axis. That would be like pitching forward. Do you see how nothing is happening? Same applies for the z-axis. So why is this? Well, in case of the z-axis, that's because the camera is trying to stay upright, and because our target is just rotating, rolling, the camera is not going to follow that because it's supposed to stay upright. If we do pitch for our object, the camera is actually constrained by its height. Why do I say that? Well, if you look at this, our camera is set to be minus 0.1 units higher than our target. Now, because the camera is behind the target, if we were to move it, that would mean the camera would actually have to move up. And that also means that the camera is going to be higher than the target. So, to affect that change, we would actually have to access this component, which is the transposer, and change this value. Right, now that we understand this, let's go and do the code. Now, on our camera target, I'm going to create a new script. And I'm going to call this script camera target. Okay, so that's our camera target control script. Oops. Give Unity a moment there. So basically the camera target control script is going to control the Y rotation of my camera target, and for the camera itself it's going to control the transposer, and we'll talk about the zoom a little bit later on. Okay, let's get in here. Now, we're going to be using Unity's new input system. So I'm going to need some functions to get my inputs from my mouse. What do we need? We need to get the inputs when the mouse moves. We also need to get the scroll wheel input for our zoom, and we need to get input for when our right mouse button is being held down, because we don't want the camera to move all the time. We only want it to happen when the right mouse button is actually held down. You can change these, and because it's a new input system, you can map them to different buttons on, say, your game controller or your joystick, whatever you're using. Okay, let's create some functions. First, we'll go public void on camera move. Call this on camera control move. And because this is for the input system, we need a callback context. Call it context. Okay, now Unity is obviously complaining about callback context because we haven't told it that we're using the new Unity input system. I'm just going to go there and press Alt Enter, and there it's added using static Unity input system dot input action. Then let's do another public function, public void on camera button. Okay, so oh my goodness, and that also needs a callback context. Tab, there we go. And lastly, we want to get the scroll wheel input. So public void on zoom input on. There we go. Got those set up. Let's go set up our controls and hook them up. Now on my input asset, which I've got here, I've already gone ahead and set up those controls, but let me show you how they work. First, we've got an action here for mouse move. The action type is a value, and the value we're looking for is a vector 2. Then the binding for it would be mouse.delta. In other words, that's the difference or the distance that the mouse has moved in a direction from the last time that it was polled. Then we've got our camera button down. This is basically just a button. You grab that there, action type button, and it's bound to our right mouse button. And then finally, we've got mouse scroll over here. And mouse scroll is going to be a value of type vector2. And the path it's bound to is scroll mouse. Now you'll also see here, I've added a processor to invert the Y. That's because I found that I like to be able to look up when pulling my mouse down, and when pushing it forward, I want to look down. So it's nice to be able to invert it if needed. Okay. Let's get down here. We've got the controls. We go to our player and we find the player input that's been added to it. We go to events, go to night. Here's our character control set up. There's our mouse move. I've already added stuff here. Do is we grab our camera target in there. Now on mouse move is going to be target control. On control camera move. The camera button down going to be on camera button, and of course on scroll wheel is on zoom input. Now you can name these as they make sense to you. The names are not that important. It's just basically trying to keep things clear. Now that we've got those functions hooked up in the editor, let's go back to the code. Now the first thing we want to do is grab our input for the movement. Yeah, I want a boolean is button down. That's false. This is a boolean that's going to detect whether or not the button is pressed. And then I want a vector2, which I'm going to store the mouse input. Okay. Mouse delta. Okay. Now that we have that, I want to do a little demonstration here. Debug.log. Now, when you press a button on the new input system, it's actually going to generate 3 calls. First, there's going to be a call when the button goes past its push threshold. That means the button was just pushed. Then, there's going to be another call telling you that the button's being held down. And then a third call when you lift up, telling you that the button has been lifted. It's going to call the same function, but when you look at your callback context, you'll see that it actually gives you the phase that it's in. So let's just log this. Plus context dot cancelled. Started. Whoops. And the last one there, going to can't remember. Context dot performed. There we go. Now what you'll see when we execute in a minute is that as the button gets pressed down, cancelled is false, started is true, and performed is false. Then on the next frame, while the button is still held down, performed will be true, started will be false, and cancelled will be false. And then the third phase is only going to happen when you release the button. In that moment, cancelled will be false. Cancelled will be true, started and performed will be false. So, if you could say which of these do you think we should set our is button down to detect when the button is actually held down and when it has been released? Take a minute to think about it while we go back to the editor and run, and I'll tell you when we get back. Okay, let's say log. A log there. Takes a little while. I hope you've guessed it by now. I'm taking the right mouse button and pushing it in and holding it. As you can see there, we've got cancelled false, started true, performed false. And the next frame, it gave us cancelled false, started false, and performed true. Then when I finally release it, it gives me cancelled true, and the other two are false. So, congratulations if you've guessed it. We're going to go performed true. Performed is only true while the mouse button is being held down. So that's what we want. Let's do that. We can delete that now. Is button down equals context dot performed. Yeah, we want to get our input when there is a mouse movement. Mouse delta equals context dot action dot read value, and the value we want to get from there is of a type vector2. Now we've got that value. Over here we want to do the rotation, but we only want it to happen if the mouse button is actually being held down, the right mouse button. So I'm going to go if is button down and do that. I could have also just gone if not is button down return, but if we have other statements we want in our update later on and we forget to move them above that statement, we might have trouble executing and not know why. Okay, so then we're going to take the transform of our camera target, which the script is attached to, and we're going to rotate it. Now, let's think about how we want to rotate. We want the left and right movement of our mouse, in other words, the X input, to actually rotate around the y-axis, because remember the y-axis is facing straight up. So if we want to walk around our character, we want to rotate around the y-axis. So we are going to add nothing to the x-axis, because that would be a tilt, and to the y-axis we are going to go mouse delta dot x, the x movement of the mouse delta, and we'll go 0 there. Now this has no control over how fast the rotation is taking place, so let's do a little something about that. Serialize field, give it a float, and we'll call it camera rotation. And right now I'm just going to make that 1. And because we want this to happen at the same speed on fast and slow computers, we're going to multiply by time dot delta time and multiply by our speed. Let's save that and go back to the editor. Hey, back in the editor now. Moving our mouse, nothing happens. Let's hold down the button. And there we have a movement. Pretty good. Let's see if our speed control works. Make that a little faster. Yeah. Good. Now, if you heard some dog barking in the background, please excuse me. It seems we can't. It seems that we can't control everything in life. But let's get back to work. So, now that we have our basic movement around the character sorted out, and we've got some speed control. Let's tune that. Let's keep it at about 2. Exiting play mode, make that 2. Now we want to actually be able to raise and lower our view. Now, I'm only going to do this for the follow cam in this video to try and keep things simple. But you can actually find a way on your Clearshot camera to find the active camera and set it for the active camera, which I might do in a follow-up video. Right, so looking at our camera, again, we go to our transposer, and what we want to change is this Y value. Now, while we're here, let's look at what a good minimum and maximum value would be. I would say that going lower than this is probably not good. So that's minus 1.5. And could probably go up to about 3 for our maximum value. Let's reset this for now. So this is what we want to happen when we move the mouse up and down. We want to grab this virtual camera, access its transposer, and adjust the Y value for that. All right, let's go. Going to get into our script here. First thing we want is to actually get a vector 2 to control the displacement. In fact, vector 3, excuse me. We want to get a vector 3 to control this offset. Getting back to our script here, we'll declare a vector 3 and the vector 3 is going to be our camera offset. We also want, no, actually cancel the vector 3. Let's just go float. Camera Y offset, because we're only going to be controlling the Y value of the offset. We'll start it off at 0. Then immediately we also want a Cinemachine virtual camera. Like that. Now on our virtual camera, we're going to grab our initial offset. So virtual camera, get machine component, Cinemachine Collider. Go. So offset. We'll grab the Y from. Where do we want to put the Y? Well, we want to our initial Y. So camera Y offset is set to that. Okay, now if we're going to continuously update this, it's going to be a little clunky. So let's actually declare a Cinemachine transposer. Go there, we'll call it transposer. Then we'll say transposer equals the virtual camera dot get cinema machine component, cinema machine transposer, and then we can just say here transposer dot m follow offset y equals our camera y offset. So initially we're going to be starting with the y offset that was actually set in the editor by the game designer. Now we want to be able to change this. So in our update, we would say y camera offset plus equals mouse delta dot y, because that's the up and down movement of our mouse, multiplied by the camera move speed or rotation speed and then we want to clamp this to the values we checked in the editor. So let's go serialized field, float minimum y offset, and -1 was a good value for that, so we'll go with -1. And we'll go out max y offset. 3 looked like a good value there. Now we're going to go transposer dot follow offset equals new vector 3 we're just going to go transposer dot follow offset dot x, because we just want to grab the x offset as it is. Y offset, going to go y camera offset come on, there we go. And then of course transposer dot follow offset dot z. So we basically want to keep those values the same and just change the y offset. Now there's one step that we missed here, and that is limit y offset, or to clamp it, math if, there we go, math if dot clamp. Value we want to clamp is that y offset and we want to clamp it to our minimum, our maximum. We don't want to go over, don't want it to go over our maximum and not under our minimum. Okay, let's see. Looks like we've got everything sorted out there. Let's test it. Oh, we have compiler errors. What did we miss? Whoops. Happens to us all, right? Let's save it. Okay, so that's rotating around. Horizontal. Moving the mouse up and down does nothing for us. Why are we getting nothing? I know why. To our camera target, we forgot to assign the virtual camera there. Go. Now that's a little quick for me. So let's give it a different variable to control the speed for going up and down. Name this. Call that the camera H rotation for horizontal. Type it out. And we'll give it a vertical rotation. Think we'll try for a value of 0.2 as a default. Over here, we'll just change that. Okay, that should work for us. Okay, let's go up and down. Here we go. And rotate. Excellent. My Unity's been giving me this weird error this last few days. Anybody knows what this is about? Please let me know in the comments. Otherwise, when I have time, I'll actually sit down and figure it out. Okay, so now we can move our camera up and down, and we can move it around our player. Let's just test our extent before we move on. All the way around here. Up and down. Notice that my camera's in the landscape there, but when I let it go and stop forcing it into position, it actually... Nope, there it stays. Let's move our player and see if it corrects. Definitely the follow cam doing that. And okay. Issue we'd like to resolve, because we don't want that to happen, although I have to say the player could probably just move the camera out of the way. Just check the normal functioning of our Clearshot. But Clearshot's still working. If I put it lower, so what's happening here, my best guess would be is that the terrain is not actually colliding with the camera. Not sure how we're going to fix that. We'll have a look at it later. Hello world, this is me coming back from the future to correct my own mistake. Even though this was supposed to be a real-time video, I felt that I had to come back and fix this quickly. Now, when I was rotating my player, you would notice that my camera was not actually always avoiding the terrain. And when I moved forward, it just kept getting worse. This was because I missed one small thing. If you go to your Cinemachine Collider, just activate avoid obstacles, and it will actually do what it was supposed to do in the first place. Now we'll go back to our regular recording. For now, let's get back to the script and see if we can do our zoom. So we've got our pan, we've got our height. Last thing for us to do now is to actually get it to zoom in. Now for this, we're going to use the mouse wheel. Go to the script. And we've got your on zoom input, and if you remember from our input manager over here, the zoom input is also a vector 2. If we log it, you'll notice something, and that is that the input actually is quite a big number for each click of the mouse wheel. So let's just go debug.log. Roll input. Action dot value, and we are looking for a vector 2, and that's going to log that vector 2 for us that we get from scrolling the mouse. Let's have a look here. Okay, grab the console, get the focus on the screen. Now, I'm currently rolling back the mouse wheel as if you would be scrolling down. This would be for me to zoom out. That's what I want. And now I'm scrolling forward. As you can see, the Y value is always 120 on this mouse, and the button, each click is 120 steps basically. Now let's see how we're going to do our zoom. If we look at the follow cam and we solo it, you'll see here that we can set the field of view. If we make it less, we zoom in, and if we make it more, we zoom out. Of course, I want to zoom in by scrolling forward, but as you can see, I get a negative value. Now what we can do is we can set a speed variable and make that a negative, or we can go into our mouse scroll here. On the wheel, we just add a processor, and you see I already inverted the Y, so let's change that and see what we get. So now I'm scrolling forward and it's decreasing, and when I scroll back it increases. Increase, decrease. Good. As you can see, we don't want to jump 120 steps each time we adjust the field of view. We want something a little slower, so we'll get a speed variable for that. And let's just copy out this one. I'm gonna go for about 12 units on each tick, so let's make that 1/20th. Oops. 1/20th. And we'll call that camera zoom. Okay, there's our camera zoom speed. And now each time this ticks, we want our field of view to change. To set our zoom, we're going to go virtual camera dot lens dot field of view, and we'll set that to be equal to context dot action dot read value. Type 2, vector 2, and we are just interested in the Y, because as you can see, when we scroll, the X comes up as 0. Now, my assumption is that a trackball would actually give us an X value as well, but we don't have one here, and let's face it, we just want to zoom in and out. We multiply that by our zoom speed. In this case, we're not going to use time.delta time, because the mouse wheel basically just triggers this function each time it makes a little tick on the wheel. So it's not going to happen in the update. Therefore, time.delta time is irrelevant. Speed. Okay, let's do this. Save it up. run it. Okay, get the focus. We can move up and down. And we can move side to side. Oh, that is way fast. And our field of view basically went directly to 1 and never recovered. Clearly we missed something in the code there. And I know exactly what it is. We want to change our field of view by the amount supplied. So that's field of view plus equals context.action.read value vector to y. Save it again. There we go. There's our sideways scroll. Sideways movement. Got up and down. And we've got the zoom. Watch the field of view value change on the side there. Now, unfortunately, I am currently zooming in when I pull my mouse wheel back, scroll down. So I'm just going to change that again. But that should do it. Okay, that's about all I'm going to do about this today. If you like the way I did this and want me to do more real-time stuff, then hit that like and subscribe button. If I can do something about this better, please let me know in the comments. And if I made glaring technical mistakes, definitely let me know so I can fix them. Until we see each other again, my name is Moni, and I make games.